In this first video of a two-part series, we're going to introduce you to open vessel level measurement using a differential pressure transmitter. The second part of our two-part series will take you through the process of predicting differential pressure transmitter outputs of open and closed tank level control loops. Before we get started, you might want to review 3 of our other videos: what is a level sensor, what is a pressure sensor, and differential pressure transmitter explained. You can find the links to these videos in the description. Even with the development of new technologies and highly sophisticated level measurement instruments, differential pressure transmitters are still in service today, measuring vessel fluid levels. In this video, we're going to discuss the 2 categories of level measurement, talk about the difference between direct and indirect methods of continuous vessel level measurement, explore how a differential pressure transmitter is used to measure vessel level, and discuss variables that influence the measurements. Okay, off we go. Level measurement can be divided into 2 categories: point and continuous. Point level transmitters are used to mark a specific single liquid height. For example, the point level sensor would send a signal to a PLC at a specific level to start a pump. A continuous level sensor measures the fluid level within a measurement range rather than at a specific single point. Said a different way, continuous level sensors provide level measurement over the full 0% to 100% range of a vessel. Because we are interested in the height of a liquid in a vessel, we take vertical measurements taken from the surface to a fixed reference point. The reference point is usually near the bottom of the vessel. You might have noticed that the vessel reference or 0% point is not at the very bottom of the vessel. This is to make sure that the vessel is never completely drained. We can take advantage of the fact that the pressure measured at the base of a liquid storage vessel will vary with the height or level of the liquid in the vessel. Armed with that knowledge, we can determine the level of the vessel from the indirect inferred measurement of the pressure. We don't have to worry about the size, shape, or volume of the tank, because none of those parameters have any effect on the pressure at the reference point. But we do have to consider other parameters, such as specific gravity and temperature. More on that later. All right, we're ready to look at how a differential pressure transmitter can be used to measure the vessel level. We said earlier that the pressure at the bottom of a vessel is directly related to the level of the liquid in the vessel. In that case, if we connect a differential pressure transmitter to the reference, or 0% point of that vessel, we can use the pressure measurement to determine the level. Another variable that has a major effect on the pressure at the reference point of the vessel is the relative density of the liquid in that vessel. Relative density is also called specific gravity. There is a relationship between pressure, relative density, and liquid height. That relationship can be expressed as pressure in inches of water is equal to the relative density of the liquid multiplied by the height of the surface of the liquid in inches. Now, let's see how we can measure the level of an open vessel using a differential pressure transmitter. The high-pressure port is connected at the 0 meters point, and the low-pressure port is vented to atmosphere. How can we predict the pressure at the bottom of the vessel? Consider our discussion earlier about the relationship between liquid height, relative density, and pressure in inches of water to determine the pressure at the bottom of the vessel for any liquid level. You can convert the resulting inches of water pressure value into any pressure scale you need, such as PSI, kilopascal, bar, etc. Let's review what we've discussed in this video. Level measurement can be divided into 2 categories: point and continuous. Point level sensors are used to mark a specific single liquid height. A continuous level sensor measures the fluid level within a measurement range rather than at a specific single point. Vessel level can be determined indirectly using a differential pressure transmitter by measuring the pressure at the 0% point of the vessel and inferring the level. For vessel measurements, pressure in inches of water is equal to the relative density of the liquid multiplied by the height of the surface of the liquid in inches. Newcomers to RealPARS have free access to one of our online courses. You can take advantage of this offer by downloading the RealPARS app and selecting the first lesson of the PLC hardware course. Just like this video, the lessons are all high quality and also very easy to follow. Also, for a low monthly fee, you'll get full access to an exclusive library of courses on PLC programming and industrial automation topics, as well as new fresh out of the oven videos each and every week. These courses are all member exclusive and are not shared anywhere else on the internet.